Good afternoon to all. During the last sessions, we were discussing about acids, bases and salts. We know that in every day we use different kinds of acids. In kitchen, we all know that vinegar, it is acetic acid, curd, it is lactic acid. Similarly, lemon water, it is citric acid. So, today onwards, once seeing these things, you must remember that these are the acids. Then, you must ask yourself some questions. What are acids? What is common to all acids? What are the different types of acids? We already studied the classification of acids, the strength of an acid. Then, how we can measure the strength of an acid? So, you make a short note on the properties of acids. These same questions may ask to bases. You are not only familiar with it, you touch with it, then you learn it. It is not an imaginary thing. These things we can see it, touch it, and feel it. Feeling must be careful. If it is corrosive, it may cause pain to your skin. The commonly used base in our house is slacker lime, CaOH base. It is used as a manure. It is used in farmhouse. At the bottom of coconut tree, we will spread slacker lime as a manure. CaOH base is a weak base. Similarly, when you see soap, you yourself to say that it is the main content of soap is sodium hydroxide or potassium hydroxide. So, you may make a short notes on these three things: acids, bases, and as well as salts. Then the last session we studied about pH scale. pH scale is we have to measure the strength of an acid as well as the strength of a base. The only thing you must remember is the pH value of a neutral solution is 7. Below 7 there are acids, above 7 there are bases. The strongest acid its pH value is nearest to 1. 1 to 6.9, the pH value gradually decreases. Strongest acid is nearly 1. Weakest acid is pH value 6.99. When it becomes 7, it becomes neutral. 7.1 to 14, it was the pH value of the bases. Strongest base is pH value 14. So, we have already studied it. Then we already studied the use of pH value in our daily life, in our everyday life. Now, we were discussing about some important compounds, their production and their uses. As well as, while we were studying the compounds, you must remember that almost all the compounds have 3 names. They can be expressed in 3 ways. First is common name, second is chemical name, third is molecular formula or chemical formula. So, once seeing a thing, you must say these names. Now we are going to study some familiar things in our forms. The first thing, salt, we are going to now study is common salt. It is its common name. Its chemical name is sodium chloride. Its molecular formula is NaCl. common salt, common name, chemical name, sodium chloride, chemical formula, NaCl. Do you know what is it? It is, in Malayalam it says, Kariyu. At home, we call it, or call him Kariyu. At the lab or experimental sessions, we call him sodium chloride. In short form, we write it NaCl. What do you know about sodium chloride? Do you know heard about Dandi March, Gandhiji's Dandi March? It's also known as Salt March, Salt Satyagraha, etc. In 1930s, when the British government introduced a special tax on salt, their aim is to increase the cost of production of the tax. Thereby, the production in India will be decreased. Therefore, they can import to India more salt from their country. So, Gandhi led a non-violence disobedience march to Delhi in Gujarat. This march also shows, it reveals the importance of salt, both of common salt in our daily life. We can't live without the usage of salt. So, Gandhi did the Diyatra. It is not salt Satyagraha. It is only now he says this. It shows the importance of common salt. This common salt is found in the solid salts in several parts of the world. It is known as rock salt. Sodium chloride is found in solid form also in several parts of the world. There it is said to be the rock salt. We obtained the rocks of the sodium chloride from this. There will be some impurities in it. We can purify it and use it. Similarly, it is prepared in the lab by the reaction between sodium hydroxide and hydrochloric acid. It is prepared in the lab by the reaction between sodium hydroxide and hydrochloric acid. Then what you obtain? Sodium chloride and water obtained. On this we get sodium chloride. On here in this, how it is formed by the reaction with sodium hydroxide and hydrochloric acid. Then the salt NaCl, sodium chloride is formed. What seeing is, we can classify sodium chloride whether it is fully normal or slightly acidic or slightly basic. The previous class, I said to you that the salts are not fully neutral. The salts are also classified into three: slightly acidic, neutral, and slightly basic. How we can classify it? When the salt is formed by the reaction between a strong base and a strong acid. Strong base and strong acid. They react with each other and neutralize. That is, if a strong base and a strong acid react, it produces neutral salt. At the same time, a strong acid reacts with a weak base. You compare it, it's a quarrel between two teams, like a quarrel between them. A strong acid reacts with a weak base. The weak base can neutralize only a part of the strong acid. So, if a strong acid is reacting with a weak base, the product or the salt formed is slightly acidic. Similarly, on the reverse, if a strong base is react with a weak acid, the weak acid can only neutralize a part of the strong base. So it is a slightly basic. What do you remember? If both the acid and base both are equally strong, the salt formed is neutral. At the same time, if one of them is more strong than the other, the salt form shows the character of the stronger part. If acid is stronger and base is weaker, the salt is slightly acidic. At the same time, the base is strong and base is strong, acid is weak. If the salt formed some acid, basic character, it is strong. Both are strong, it is neutral. If either of them is strong, the salt also shows the character of property of that part. Now we are studying about sodium chloride, say neutral salt, because it is formed by the reaction between sodium hydroxide and hydrochloric acid. Both are strong. Sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. So the salt form is fully neutral. Neither acidic nor basic. Then we have seen that what are they? It is it is prepared in laboratory by the reaction between sodium hydroxide and hydrochloric acid. Similarly, it is found in the solid state, solid salt in different parts of the world. In the form, it is called a rock salt. Rock salt. In Malayalam, it says Uppupara. Uppupara like the rock salt. Similarly, when the seas dry up, the sea bygone areas also it is found. The main source of salt is seawater. The main source of sodium chloride is seawater. Because by the evaporation of seawater, we produce salt, and then we feed and kept in packets and distributed in shops. Thus we buy the packets from the different shops. It is prepared by the evaporation of seawater. Then it is what is the use? The use one of the main uses it is used in our daily food. It increase the taste of food. That is so. In early times, it is used as a preservative also. The vegetables or the meat is mixed with salt and kept it for 2 or 3 days without it undergo any decomposition or decay. So it is used as a increase the taste of food. It is used as a preservative for food, as well as it is used for the production of other compounds of sodium. It is also used for the production of like sodium hydroxide. It is also used. So one of the important compounds is common salt. These you are familiar with. The second is sodium hydroxide. Sodium hydroxide. It is its chemical name. Its common name or industrial name is caustic soda. Caustic soda. Caustic soda is common name or industrial name is caustic soda. Chemical name sodium hydroxide. Chemical formula NaOH. NaOH. How it is prepared? How it is prepared? It is prepared by the electrolysis of aqueous sodium chloride. What do you mean by aqueous sodium? Aqueous means in every substance, the water solution of a substance is called aqueous. Aqueous. Aqueous means from aqueous we gave the name aquarium, that is water. Aqueous means the term aqua means water. So aqueous solution means water solution. You are familiar with the word aquarium, AQU. They are similar. The usage is the same meaning. That is aquarium. That is aqueous solution. So sodium hydroxide is prepared by the electrolysis of aqueous sodium chloride. Aqueous sodium chloride is also known as brine. Brine. Brine is the commercial name or the industrial name of aqueous sodium chloride. Aqueous sodium. Electrolysis means the decomposition of a substance due to the passage of electricity through electrolysis. Certain substances undergo decomposition on the presence of electrolysis. That is electrolysis. Similarly, hydrolysis also. Certain substances undergo decomposition in presence of water. That's known as hydrolysis. The electrolysis of brine. Brine means brine. Brine means sodium chloride solution. Sodium chloride solution means sodium chloride or common salt dissolved in water. We can see how it is produced. You must see this. This is a big tank. This is a big tank in which brine solution is taken. This is brine solution. This is the entrance for brine solution. BRINE. Brine. Brine means aqueous NaCl. Aqueous sodium solution is entered here. Then this is the anode and cathode. This is anode and this is cathode. This is the exit for chlorine and where it is and hydrogen. This is exit for hydrogen. This is the sodium chloride. Here we can, on the bottom of the tank where sodium hydroxide is, sodium hydroxide is kept. It is taken out from this tank. Here we please note these things. The previous class I said to you that cathode, anode, cation and anions. Cathode is the electrode connected to the negative pole of the cell. Anode is the electrode connected to the positive pole of the cell. In that class I already told you that the symbol of a tricycle is this. Two lines, one is big and one is tall and short. The tall line shows the positive part and this is symbol of a tricycle. This is the big line is the positive pole and the small line is the negative pole. The electrode connected to this is the electrode. The electrode connected to the negative pole is called cathode. This is cathode. This is electrode connected to the positive pole is anode. This is anode. The solution taken is what? Na positive as well as Cl negative. Similarly, H positive as well as OH negative. Sodium chloride, when it dissolved in water, NaCl, when dissolved in water or in aqueous solution, it always, as soon as it dissolves in water, it dissociates into Na positive and Cl negative. Similarly, when a slight electrolyte is present, water also undergo dissociation to give H positive and OH negative. Water H2O gives H positive plus OH negative. H2O gives H positive plus OH negative. Here we look here. Cathode is the negative electrode. Negative electrode means electrode connected to the negative pole of the cell. How we can identify negative pole of the cell? The symbol of a cell is this: a short line and a tall line. Short line is the negative part and tall line is the positive part. Negative is connected to the cathode. Cathode is negative charge. Cathode attracts which ions? Cathode is negative charge. It attracts positive ions of the electrolyte. So here sodium ions and positive ions, sodium ions and hydrogen ions can move near to the cathode, where hydrogen is an gaseous state. It evolved through heat. Hydrogen is evolved through this exit. At the same time, chlorine and hydroxide, they are negatively charged. They move towards the positive electrode, which is the positive electrode anode. This is positive electrode. Then chlorine is go outside through this. Here chlorine is went outside. Here chloride is. What is left here? Sodium hydroxide remains. They couple into form sodium hydroxide. They can be taken out through this. So, on aqueous solution of electrolysis of the aqueous solution of sodium chloride, what are the products obtained? You remember that aqueous solution of sodium chloride means sodium chloride, the ions present in the sodium chloride as well as the ions present in the water. What are the ions present in the sodium chloride? Na positive and Cl negative. What are the ions present in the water? H positive and negative. Here cathode. Cathode is the negative electrode. It attracts the positive ions. What are the positive ions? Hydrogen ions and sodium. The hydrogen ions and sodium ions moves towards cathode. Whether hydrogen ions in the gaseous state is escape through this outlet. These sodium ions and hydrogen ions are called what? The ions move towards the cathode are called cations. Cations. They are positively charged. The ions move towards the anode are called anions. They are negatively charged. Here, in this process, we obtained three products. At cathode, we obtained chlorine. At anode, we obtained chlorine. At cathode, we obtained hydrogen. At cathode, we obtained hydrogen. At anode, we obtained chlorine. At the bottom of the electrolytic cell, we get sodium hydroxide. What is our aim? To produce sodium hydroxide. It is taken out through this outlet. This is the entrance of a bright solution. This is the commercial production of sodium hydroxide. This process is known as chlor-alkali process. The name of this process is chlor-alkali process. Chlor-alkali process. Why it is called chlor-alkali process? the main products in this process is chlorine and then sodium hydroxide alkali. We know that sodium hydroxide is a base as well as alkali. What are alkali? The water soluble bases are called alkali. It is a part of base. All the bases are not dissolved in water. Certain bases like sodium hydroxide and potassium hydroxide only dissolves in water. Such bases are called alkali. So, the production of sodium hydroxide is industrially produced by the process namely chlor-alkali process. Here there will be a number of short answer questions. You may study, learn and study each line and each word. Name the compound which is produced by the chlor-alkali process. Name the compound which is produced by the chlor-alkali process. Sodium hydroxide. So why this process is known as chlor-alkali? Because in this process, the main products obtained are chlorine and sodium hydroxide. So it is known as chlor-alkali process. Once again, there is another question on the electrolysis of brine solution. Brine means aqueous solution of sodium water. What are the products of obtained at cathode and anode? Then there is no generalization, no description. What are the products obtained at cathode and anode? Only two ways. What are they? At cathode, hydrogen. At anode, chlorine. There are no detailed description is needed in such a question. In the previous examination, there is a question asked: what are the products obtained by the electrolysis of water? Only two words. At cathode, hydrogen. At anode, oxygen. There is no detailed description. What are the products obtained? Means you must refer only the name of the products only. So then where we get the sodium hydroxide at the bottom of the electrolytic cell. Then what are the uses? Sodium hydroxide is used in the manufacture of in paper industry, soap, detergents, etc. Now we already soap is the main. Whenever you see the main product of soap is the main named sodium hydroxide. So it is also used in the paper industry and detergents, etc. So it is used. It is also used in the degreasing of the metal. You know that. What is degreasing? In your kitchen, your mother always used dishwash soap. Dishwash means if dishwash soap is used, we can easily remove the fat like impurities. And fat like, so it is using for the removing impurities of the degreasing methods. The next important substance is bleaching powder. Bleaching powder. This chemical, this bleaching powder is its common name. Its chemical name is calcium oxychloride. Calcium oxychloride. Its chemical formula is CaO2. CaO2. Whenever you add these things, you must always remember these are your in your form. So you take these things in your hand and call it its chemical name, its chemical commercial name, and you must write its chemical formula also. It is how bleaching powder is a familiar thing. It is used for bleaching, purifying water. It is used as an oxidizing agent in paper industry, bleaching materials, etc. It is used. How it is produced? It is produced by the action of chlorine or tricyclide. What is tricyclide? CaOH twice. One passing chlorine, it will produce CaOH, CaO, Cl2 plus H2O. How bleaching powder is in this substance? You have to remember these things. Its chemical name, chemical formula, its production, and the main uses. How it is produced? It is produced by the reaction between chlorine and silicate. Silicate we have already studied in the previous classes. Silicate, CaOH is a weak base. One passing chlorine through tricyclide, not wet. In tricyclide, the product bleaching powder is formed. It is used as a main purpose is same bleaching purpose. Similarly, it is used as in not bleaching in purifying water. Purifying water is also used in the drink water. The municipal town area, you get the smell of chlorine in pipe water from not from the well. They are using the public water. You can smell that water is purified by adding bleaching powder in bulk amount to it. It's used as a disinfectant in several parts. This is the disinfectant is the chlorine, where the chlorine is kept in the stored in the silicate. So near the new product is CaO, Cl2. So you must remember this. How bleaching powder? Bleaching powder is common name bleaching powder. Chemical name calcium oxychloride. Calcium oxychloride. Chemical formula CaO, Cl2. The next product is baking soda. Baking soda. Its chemical common name is baking soda. Chemical name is sodium hydrogen carbonate. Sodium hydrogen carbonate. And its chemical formula is NaHCO3. How it is prepared? It is prepared by a reaction between NaCl plus H2O plus CO2 plus NH3. Then the product formed is NaHCO3 plus NH4Cl. Baking soda is prepared by heating these things. What are they? Sodium chloride, H2O, CO2 and NH3. The product formed is NaHCO3 plus NH4Cl. On heating it produces Na2 on heating NaHCO3 it produces sodium carbonate HCO2 plus H2O. This is baking soda. The next thing we are going to study is baking powder. In our kitchen, making cake or appam, we use baking powder, not baking soda. If baking soda is used on heating or mixed with water, it produces Na2, sodium carbonate. It has a bitter taste, so it is not suitable. It is sodium carbonate. It is sodium bicarbonate, it is used mainly for the production of baking powder. Baking soda mixed with the edible mild acids, we get baking powder. You must please remember the baking powder. There is a difference between baking soda and baking powder. Baking soda is mixed with an edible mild acids. Edible mild acids. So edible means usable. Mild means weak. So that commonly used edible mild acid is tartaric acid. Where the use of edible mild acid is to give H plus ions. So, on heating NaHCO3 plus H positive ions, H positive ion is the mild beauty of the function of the mild acid is to give H plus ion. It produces CO2 plus H2O plus sodium salt of acid. This is our user for carbon dioxide. This carbon dioxide gives spongy and soft. Gives the rising of the cake or appam is due to the presence of the production of this carbon dioxide. Thus gives a spongy and softness to our bread or cake. So, you must remember the difference between baking soda and baking powder. Baking soda is NaHCO3, sodium hydrogen carbonate. Baking powder we use in our bakery is baking soda mixed with edible mild acids. How it helps in rising or baking in the cake or cake is smooth and soft. When it is baking powder, when it is heated or mixed with water, baking powder, when it heated or mixed with water, it produces carbon dioxide. This carbon dioxide helps in rising of cake and as well as it gives softness and spongy touching to the cake and etc. So today we have to study what are these four things? What are they? Common salt, sodium hydroxide, bleaching powder, and baking soda. This baking soda or sodium bicarbonate is used as an antacid also. It's a mild acid. It is used as antacid. It is sodium hydrogen carbonate is also used in the fire extinguishers. When it reacts the acids, it produces carbon dioxide. Whenever you get fire extinguisher, you must remember that if a fire is extinguished, there must be the presence of carbon dioxide gas. Carbon dioxide gas removed, the oxygen, there the fire must be extinguished. So, why it is used in fire extinguishers? It reacts with the acids and produces carbon dioxide helps to the fire extinguisher. So, today's class is over. We can see the next class. Okay, thank you.